Okay, good afternoon. Can everybody hear me? Oh, good. Okay, so we're going to talk about SNC's new Vista SD solid dielectric switchgear. It's on display over in our exhibit, so afterwards or anytime this afternoon or tomorrow, feel free to stop by and take a look at it. I suppose that begs the question, why develop solid dielectric switchgear? Because there's a lot of existing SF6 switchgear out there. And I think the answer is that SF6 gas as an insulating medium's got an uncertain future. It hasn't been legislated out of existence yet, but there's a lot of regulations at play. And some utilities are no longer purchasing SF6 insulated switchgear. And those that are have to inventory how many pounds of it they have and how much they leak. So that's a nuisance. So solid dielectric solves that problem. And then also there's a need for compact submersible switchgear that's a little more flexible in terms of its installation style in vaults or in pad mount. You'll see when you see this solid dielectric gear, it's a little more vertically oriented, so it'll fit into a vault a little bit better than other kind of gear that's a little low profile and a little bigger footprint. So let's just scan through the benefits. The first one's obvious, no SF6 gas, solid dielectric. Variety of installation styles, submersible vault style and pad mount. We'll see some pictures of that later. It's factory assembled and tested in lineups of up to 6 ways. In some respects, the solid dielectric Vista offering mirror images our existing SF6 Vista offering, so you'll see a lot of comparisons there. Easy to operate from a variety of positions. We understand that today's paradigm is that nobody wants to stand in front of the switchgear when they operate it, so this switchgear has been designed to operate from the side or using a motor operator. You can operate it remotely in that way. What else? Easy to follow position indicators and mimic bus. We spent a lot of time developing this gear specifically with the idea of, is it easy to see that it's open, easy to see that it's closed, a visible open gap, which we'll talk about in a minute. These are all things that make the switchgear easy to operate, easy to understand what position it's in when you go up to the switchgear. Easy to install. So it's got a very balanced lift. You hang your slings on it and lift it up, and it stays balanced as it's being hoisted. Visible gap. Now, we call it the isolating disconnect. This is very important. Now, remember, this is solid dielectric gear, and it's not easy to come up with a visible open gap in what is otherwise a solid piece of equipment. So we do have a visible gap. It's called the isolating disconnect, and that's in keeping with North American practices. So it's a very, very important feature to confirm that the equipment is open or closed, as the case may be. We have a variety of motor operator options. You can get motor operators installed from the factory, or you can get a motor operator as a portable motor operator and then just put it on when you want to switch a particular switch or fault interrupter. So in that respect, that's the operating it locally, but yet being remote from the gear while you're doing it. Field replaceable bushings and bushing well adapters. Kind of the historical situation was you had these threaded bushings in our SF6 gear, and if you were to cross-thread the stud when you're trying to put the terminations on, now you've pretty much taken that piece of equipment out of service. So with the new solid dielectric gear, we have replaceable bushings. So if you cross-thread one when you're installing it, you can replace it. Or if you have a cable termination failure that doesn't damage the equipment, but it only damages the termination, you'll be able to replace that and the bushing in the field. So that's kind of neat. Uses the Vista overcurrent control. So this is the overcurrent relay that comes with our existing Vista switchgear that we've had on the market for about 20 years now, so it's very reliable. Same relay for Vista SF6 gear will work on the solid dielectric gear. And then lastly, a lot of options and features and things to match whatever your specific needs are. Here are the ratings, 17.5 and 29 kV max, 600 amps continuous, and 16 Ka short circuit interrupting at 17.5 kV, 12.5 Ka short circuit interrupting at 29 kV. Okay. So this is what it looks like. There's 2 different installation styles. This is the vault style. You can see that it's fully submersible. We're going to give it an IP68 rating. The 6 means it's dust tight, and the 8 means that it is watertight to a time and a depth as determined by the manufacturer. In our case, we've chosen 10 feet for, 10 feet for 30 days. So our definition of IP68 is shown here. We also have a pad mount style. So it's the same equipment. It's completely submersible. It's just installed in a pad mount for above grade installations. This might be of interest to the utilities in the states that get hurricanes, because as we know, it's not the hurricane does the damage, it's the flood afterwards. So even though it's pad mounted style, it's still completely submersible. Now let's talk about configurations. This is a single way configuration, and this is ideally suited for network vaults. So as I say, it's one way. All 6 bushings are on the front. The top set of 3 bushings would be your incoming bushings. The bottom 3 bushings are your outgoing to your protected way. This is the fault interrupter version, and this is what we have on display over in our exhibit. You can install this on its back if you want to, and you can even flip it upside down. So if you have cables on the top, mech on the bottom, you can do things like that. This is a multi-way version, and this particular one has the bushings on the top, so this would assume that the cables are coming across the ceiling and drop down to the gear. Operating mechanism is on the bottom, and as I said, you can flip that over and have the mech on top and the cables on the bottom if that's the way your vault is designed. It's front accessible, so it's intended to be pushed up against the wall. So let's just look at some of the components. This is the load interrupter switch. There's 2 basic components, a fault interrupter and a load switch. So this is the load switch. It's manual. It's 3-pole operation, and it uses a load switching vacuum bottle. So it's basically a vacuum load switch. The dimensions and the weight are shown there. Now the fault interrupter looks pretty much the same. It's also manual, 3-pole, uses fault interrupting vacuum bottles in order to get the short circuit ratings. Same dimensions and the same weight. Okay. So what else do we have? This is what the operating mechanism looks like. And let me see if I can use the laser here. It's not going to show up. Well, the operating shaft's on the left. You can put a manual handle on this shaft, and you basically rotate it one direction to open it, rotate it the other direction to close it. We spent a lot of time, as I mentioned a moment ago, on the state indication. So here you see 2 ways to tell that this is in the closed position. You see the red target. Red means closed, and in a second I'll show you green is open. And you'll see that there's a mimic bus with the semaphores, and those flags will move to show that it's in the open position. So this is closed, and this is what open looks like. Now the third way to tell if it's open is to look at the visible open gap, the isolating disconnect, and I have a picture of that in just a second. So that's it, basically operate it one way to open, operate it the other way to close. If it's a fault interrupter, you may find that the interrupter is tripped, but the disconnect is closed. So then you operate it into the open position to reset it, then you operate it to closed after you've cleared the fault. So in terms of operating it remotely, you can operate it by hand if you choose to. You can tie a rope onto the handle if you want to. You can use a shotgun stick, or the other way to operate is to put the motor operator on it, which I'll show you in just a second. So here's the visible open gap, or the isolating disconnect as we call it. It's quite large. It's about 3 inches by 5 inches, and it's quite visible. Interestingly, even with the cables installed, if you just offset yourself, you can see through the cables, and you can see the disconnects either opened or closed. If it's a fault interrupter, you get current transformers. It's a self-powered device, so you don't need control power just for the fault interrupter or for the relay. It's powered off the CTs. This is the relay. The relay's in a submersible box. You program the relay with a personal computer, so you basically take the plug off that one port, and then there's a jack, and you plug your computer into that jack, and then you can program the relay. There is potential indication as an option. It's kind of European style, so it gives you the 3 jacks, 1, 2, 3, and the neutral, so you can do phase-to-phase and phase-to-ground voltages. You can do phasing with that using just a low-voltage meter. And parking stands, if you want to move cables. Typically, you don't move your 600-amp T-bodies, but if you get a protected way with maybe 200-amp elbows, and maybe your practice is to pull the elbows and ground them, you can get the parking stands to do that. There is a continuous ground bus option, because if you think about it, in addition to grounding the switchgear itself, there's a lot of other things you have to ground. The concentric neutrals on the cables, the drain wires on your T-bodies and things like that. So having a continuous ground bus is just a convenient way to land all those other terminations. And then the mounting stand. As I mentioned before, you'll specify the mounting stand when you order it, and then that will tell whether that's a mech on top, cables on the bottom, or cables on top, mech on the bottom. Now here's the pad mounted enclosure. As I mentioned before, it's completely submersible. This particular design of solid dielectric switchgear is all inline, so this matches our existing Vista offering. It's a common cable termination compartment. It's not isolated per way. This is what it looks like when you open it up. So when you put it in the pad mounted style, it's kind of automatically mech on top, terminations on the bottom. And what's not visible in that previous shot is that there's a horizontal steel panel across the cable termination compartment. So that basically separates the cable termination area from the operating compartment. So when you're operating it, you only have to have access to the mech. You don't have to have access to the cables. This the panel there is also a convenient place to put your computer when you're programming the relay. Here's the motor operator. It's really a slick design. When you have a motor operator on a piece of switchgear, again, the first context of that would be to operate it remotely. You unwire the pendant and hide behind the tree and push the button. But then it isn't too long before you get into source transfer, remote supervisory, SCADA applications, and so forth. Now, when you do that, you're going to want to decouple the motor in order to test it. So in this particular design, you pull out the motor, you rotate it a few degrees and push it back in. That decouples it. Now I can test the motor independent of the switchgear. So it's a really slick design. It's also easy to install and remove. So for the portable motor application, you can just add it very quickly. Now, it does require a control power. Here's the pendant. This is the pendant that's cable connected to the motor operator, and you can see all the push buttons. We have an enable push button that you have to hold down before you push the open or the closed button. That's just to prevent you from accidentally pushing a button and opening up the circuit. There's two sets of lights. One follows the motor operator, and the other follows the isolating disconnect. So when you buy the motor operator from the factory, you'll get the auxiliary contacts brought out, and that will go into the pendant, and then now you get confirmation that the isolating disconnect is open and the motor's open. Now, if you decouple it and then you change the state of the motor and they're out of sync, you can't recouple it. So that's your signal that they're out of sync, and you have to put it in the right condition, and then you'll be able to recouple it. And I believe that's it. So I have a whole minute 54. I'd invite you to come over to our exhibit and take a look at this gear. And if you have any questions, I can either take them now real quick or over in our exhibit. So thank you very much.